Hi, I'm Niharika. In this video, I'm going to talk about the peer graded assignment project by Machine Learning Foundations for Product Managers by Duke University. Coming to the project, this project we will build a model to predict the electric energy output of a combined cycle power plant, which uses a combination of gas turbines, steam turbines, and heat recovery steam generators to generate power. This project will be evaluated based on the following four elements, that is modeling approach, model building, model evaluation, and model interpretation. Coming to the first step, that is the modeling approach. This problem is a supervised regression task because the target variable power output is continuous. The data set contains around 9,568 observations with the four following features, that is, the temperature, ambient pressure, exhaust vacuum, and relative humidity. To solve this problem, I selected linear regression as my modeling technique because it is simple, interpretable, and effective for continuous prediction problems. I've built two models. One is the model one is based on the four features, all four features, whereas the model two is only for features, temperature, and vacuum. This helped me to compare a full model versus a simpler model. Coming to the next step, that is the data preparation and splitting. I have split the data into the training data and the test data. Training, that is 80% of the training data and 20% on the test data. The training data was used to build the model, while the test data was used to evaluate performance on the unseen data. This ensures that the model generalizes very well and avoids overfitting. Next step in the project is the model building. Using the training data set, I applied linear regression to estimate coefficients for each feature. That is, the model one include all the features, whereas the model two includes only two features, that is a temperature and the vacuum. I then used regression coefficients to generate predictions for both training and test data sets. Coming to the evaluation of a model. To evaluate performance, I used root mean squared error, which measures the average prediction error. The results showed that the Model 1 achieved lower RMSE on both training and test data, whereas the Model 2 had higher RMSE, indicating lower accuracy. This confirms that including more relevant features improves like prediction performance. Next is the model comparison and the interpretation. The results indicate that environmental factors such as pressure and humidity significantly impact power output, not just the temperature and the vacuum. Additionally, the differences between the training and test RMSE was small, which suggests that model is not overfitting and performs consistently on new data. I also visualized the results using an actual versus the predictor scatter plot, which showed stronger alignment. Also, an RMSE comparison chart, which clearly showed how Model 1 outperforming Model 2. The last step of the project is the conclusion. I conclude this project by saying that this project demonstrated how machine learning can be used to predict power plant energy output using environmental data. Um, as mentioned earlier, I've built and compared two regression models and found that using all available features leads to better accuracy. Model evaluation using RMSE helps in selecting the best model. Proper data splitting ensures reliable performance. From a real world perspective, this type of model can help power plants to improve their efficiency, to optimize the energy production, and support data driven decision making. Overall, this project highlights that the importance of the feature selection, the model comparison, and the evaluation in building effective predictive models. Thank you all for giving me this opportunity to present this project. Thank you once again.